we're going to be comparing linear and exponential growth functions. Both functions will be presented in tabular format, and we're going to generate terms using the table and their respective formulas, and basically see which one has a higher value after a certain period of time. Okay, so the question reads, the table below shows the weight of Liam's pumpkin, L of W, and Patricia's pumpkin, P of W, over a 4-week period, where W represents the number of weeks. Liam's pumpkin grows at a constant rate. Patricia's pumpkin grows at a weekly rate of approximately 52%. Question: assuming the pumpkins grow at these rates through week 13, when comparing the weights of both Liam's and Patricia's pumpkins in week 10 and week 13, which statement is true? So basically what we just have to do is figure out the weight of Liam and Patricia's pumpkin in weeks 10 and week 13. Okay, and then we're going to know what the answer is. Alright, so we are told that Liam's pumpkin grows at a constant rate. Okay, so what does that tell us? If a function has a constant growth rate, what does that mean? Well, certain things that you want to note concerning growth rates. If you have a constant growth rate, that indicates that you add a difference over and over again. You're going to be adding the difference repeatedly. Alright, and in this scenario, what you have is a linear function. Linear functions have constant average rate of change, or constant rate of change, or constant growth rates. Now, in the case of Patricia's pumpkin, we have a growth rate of approximately 52%. Now, when you have a percentage growth rate, in this case, what you do, instead of add, you multiply. Okay, so you multiply by what? You multiply by 1 plus the percentage growth rate. And in this scenario, we have an exponential growth scenario. Okay, exponential growth function. Alright, so when you have a constant rate, is a linear function, just like a straight line. And then for the second one, if you have a percentage growth rate, is an exponential function, which is a function whose rate of change increases over time. Okay, alright, so with those two in mind, let's see if we can generate formulas for Liam's and Patricia's pumpkin. Okay, so for Liam's pumpkin, we want to see what L of W looks like. So for Liam, we have L of W. So since for L of W we have a constant rate, what are we going to do every single time? Well, we have to determine what the growth rate is. So from 2.4 to the constant difference, from 2.4 to 5.5, if you do the calculations, 5.5 minus 2.4 is 3.1. So you add 3.1. And then just to test it, if you add 3.1 to 5.5, guess what? You get 8.6. If you add the constant rate, which is 3.1, to 8.6, you get 11.6. Okay, so for the function L of W, what you do every time for the constant rate is you add the difference, which is what? 3.1. So add 3.1 every time. Alright, is an additive relationship. Now for Patricia's scenario, we have a constant growth rate. Okay, we have a variable growth rate. The variable growth rate is 52%. Okay, the percentage growth rate is 52%. So what does that tell us? For Patricia's weight function, we have a 52% growth rate. So what does that mean? That means that we're going to multiply by what? Multiply by 1.52 every time. Now, how did that happen? Well, 52% in decimal form is 0.52. You move the decimal point to the left 2 places, because when you're converting from percentage to decimal, you divide by 100. So move the decimal point to the right 2 places. Alright, so this is a percent growth rate, but since it's a growth rate, you're going to add 1, just like exponential functions, exponential growth models. You add 1 to that. That is why I came up with 1.52. So you multiply 1.52 every time. Now, something you want to note is that it's an approximate growth rate. Alright, so some rounding will be done in the determination of the weight in pounds for Patricia's pumpkin. So let's see if this is the case. Since we're multiplying decimals here, it's more effective for us to use a calculator. So what we're claiming is that what's happening is we're multiplying by what? We are multiplying by 1.52 every time. Okay, so from here to here, you multiply by 1.52, 1 plus the percentage growth rate, and then you repeat the same process over and over again. So let's test it just to make sure it's correct before we move on to determining what week 10 and 13 are. So 2.5 times 1.52 is 3.8. Bam. And then the next one, 3.8 times 1.52 is 5.776. So you see how they rounded it up to the 10th place. Okay, so they rounded up to 10th place, which is 5.8. So we go 5.8 times 1.52, and we get 8.81, rounded again. So we can see that what's happening here is we're multiplying by 1.52 repeatedly, and that's what an exponential function is all about. You constantly multiply by that growth rate. Alright, so to get week 10, what are we going to do? To get week 10, all we're simply going to do is add 3.1 to 11.7. Alright, that's not difficult to do. We just add 3.1 to 11.7, we get 14.8. And then how do we get week 10 for Patricia's pumpkin? Follow the same pattern. Multiply by that common ratio, which is 1.52. So multiply by 1.52. And let's see what that answer is. So we have 8.8 times 1.52. And we're going to round to the first decimal place, or the 10th place. Alright. Multiply, we have 13.376. If we round up, that's going to be 13.4. Alright, so it's going to be 13.4. Now we can make a comparison here. Which one weighs more? We can see that Liam's pumpkin weighs more at week 10. Now, since the linear function has the lead, does that automatically mean that Liam's weight will remain the greater? Well, let's see. Let's take a look at what happens at week 11, 12, and 13. And when we get to 13, we're going to compare again. Okay? So all we're just going to be doing here is just for Liam's function, it's easy. We're just going to keep adding 3.1. So we add 3.1. And then we get for week 11, we get, what do we get? 17.9. And then we add another 3.1. For week 12, we're going to have 21. And then for 13, the last one, you add another 3.1. And then you have, let's see, 24.1. Alright, so that's that for Liam's weight. Now let's take a look at what the situation is with Patricia's pumpkin's weight. Okay, so what we're going to do, we're going to repeatedly multiply by 1.52. Okay, so multiply by 1.52 to get the weight for week 11, 12, and 13. Let me put a line there so that we can see what's going on. So this is for week 10, and this is week 11, and this is week 12, and then we're going to separate them from left to right. Okay, now let's do it. We're going to use a calculator here since we're multiplying. We rounded it up, so 13.4 times that common ratio, which is 1.52. Enter. We have 20.4. So 20.4. Oh, look at this. The exponential function has already exceeded the linear function. Now that shouldn't come as a surprise because a linear function has a constant growth rate, whereas an increasing exponential function has an increasing growth rate. So if you have an increasing exponential function and a linear function compared with each other, at a certain point in time, the exponential function is going to catch up and exceed the linear function. But the question is, when will that happen? Okay, so we can see that the exponential function has taken over, and guess what? The exponential function will maintain the lead because it is a function with an increasing growth rate, whereas the linear function has a constant growth rate. Okay, so let's see. 20.4, we're going to multiply that by the growth factor 1.52, and that gives us 31, just 31 as a whole. See, the lead is widening now. And then lastly, we're going to multiply 31 by 1.52 to get what the weight is in week 13. Alright, so we're just repeatedly multiplying by 1.52. Alright, we already know that the exponential function will win, but let me just show you. So 31 times 1.52. Let's do that again. 31 times 1.52. And your answer is 47.1. Wow, you see who the winner is? It's the exponential function. Alright. Okay, so let's see what's the correct answer. Liam's pumpkin will weigh more in week 10 and 13. The answer is that's wrong because Patricia weighs more in week 13 and Liam weighs more in week 10. Alright, so Patricia will weigh more in both weeks. No. Option 3, Liam's pumpkin will weigh more in week 10 and Patricia's pumpkin will weigh more in week 13. Absolutely, that's what's happening here. The answer